Our next speaker is Brett Schneider, President, CEO, and Chairman at CarbonConversions. So Brett, turn it over to you. Thank you. You're on mute, Brett.
That's why we test. Can you hear me now?
Yes.
Great. Good morning, everybody. Thanks for the great introduction there by Acme and some of the history there that CarbonConversions has been a part of. And thanks to the American Carbon Society for having us come on and present today. So we're going to talk a little bit about CarbonConversions, and this is really a building story from what you've just heard. CarbonConversions is a company in Lake City, South Carolina, that has really, for the last 12 years, been a bit of an R&D creation hub, but over the last 4 or so of those 12 years has really started to commercialize and scale the recycling. And so we like to say that we're pretty successful at doing this. It's not a research project anymore, and we're making a business of recycling carbon fiber and closing the loop and bringing carbon fiber back through pyrolysis or other recycled forms we can get to, and making value-added compound additives or non-woven materials. So with that, we'll walk through a little bit of who CarbonConversions is and kind of how we think about the world, and then take some questions on what we can do going forward. So Lake City, South Carolina, we've got a great team in place. We've got a 100,000 square foot facility. We manage inbound raw goods from a variety of different waste streams. We convert those raw goods through different processes to chopped form, and then a lot of that becomes non-woven form. We do that for both thermoset and thermoplastic materials, and then we sell to people who make parts, and they do that through infusion, high pressure infusion, compression molding, or injection molding. So there's a lot of different ways you can take the products back into something viable. Our goal is to close the loop around carbon fiber. We focus on carbon fiber. We don't do a lot of other fiber forms. We're a good, sustainable supplier, material developer, and we've been a great partner to a variety of customers, Collins included. We are profitable. We provide a stable, qualified, on-time ISO environment. We track all the inbound raw materials, and we'll talk about that a little bit, because we believe you want to get the modulus back to the customer. So the modulus is where the value is, and if you don't track your IM or your standard moduluses, then you end up providing sub-performing products which don't have the value back in the supply chain they should. So we track modulus, we combine it with different material formats and chemistries to provide that value back. And in 2021, this year alone, we'll recycle 1.5 million pounds, keep that out of the landfill, and provide it back as a value-added product to the customers. So just at a high level, from a waste perspective, what do you do with 180 million pounds of carbon fiber a year? I think Dan had a little bigger number yesterday we were talking about, and this is a bit old, but as the aerospace recovery happens, I think the volumes here are only going north, especially with the new announcements and expansions. So 2 to 4% of this volume is wasted by the producers. It comes from the precursor or the fiber lines itself, and we get access to that. 30% more is wasted roughly as intermediates. So as you weave it, you make it into non-crimped fabrics, you put it down a pultrusion line, you put it through a winder. There's a lot of intermediate waste in that process, and we try to capture that. And then what we're starting to talk about as an industry is, once you've produced your part, then it has a life of doing things, right? It travels around the world, it spins in the air, it creates services, it does defense. But as those things age out at the end of life in 20 to 30 years, those become large volumes of reclaimable carbon fiber that has a lot of value. And we're now starting to see that in the industry come back. And so we're learning how to use those different waste streams and put them back into something value added. So we also think about demand going up, and capital assets are expensive. So we don't believe carbon fiber gets a lot cheaper going forward. In fact, given the cost of oil today and the cost of assets as you build in inflation, carbon fiber probably costs more in the future. So the idea of using a recycled fiber that does save an awful lot of the expense of making the virgin fiber does make a lot of sense if these product forms can work for you or you can design them in. We think there's a lot of value in the tensile and the modulus, and we know that the modulus is recoverable. The tensile can be, depending on the chop length and how you get alignment in a fabric, but for the most part, we're talking about bringing modulus back to the industry. And we know how to do it. We know how to close these loops, so we know we can be successful at it. So it's really about working with customers to bring it back around full circle. Just a quick graphic. If you don't want to recycle and reuse, and this is the process on the left that we go through in making and consuming carbon fiber, then what you get on the right is what happens in the world, right? You get a bunch of intermediates that all go to the landfill, and you get a bunch of end-of-life products that eventually will all go to the landfill. And as you can see, they often get parked in the desert or buried in the desert, and that's just not good for the environment. It's not good for the industry, and it's certainly not good for the overall cost structure of how we could use these things more efficiently. So all of those intermediates that you see in that column we use today, and we're already working on a lot of those end-of-life applications and bringing those back through into value-added product forms. So when we think about carbon fiber from a recycled perspective, we've done a lot of work over the years around the value of that, how to think about the value of that. So fiber tow is the most expensive fiber form you can get. It's at the top of the pyramid. It also has the most value from a tensile and modulus perspective. It's not been handled, and we love to get that type of product from the in-process people. But if you drop down into fabrics and braids and what we call as other dry process waste, that has a lot of value because it hasn't been too damaged. If you drop down into unidirectional and fabric prepregs where they've been wet out with either a epoxy or a thermoplastic in some cases, you're starting to lose a little bit of the value. The energy required to get at that modulus and back into a product form starts to go up. And then you get down to this post-consumer world, end of life materials. The modulus there is still very credible. It's still easy to use, but it does, again, take a bit more energy to get at it. And so we look at this as there's a lot of value in your waste streams at the top of this pyramid versus the bottom of this pyramid, but modulus holds throughout that whole story. And so as an industry, mostly started towards the top of this pyramid, but now we're learning how to use the bottom of this pyramid. So as these things reach end of life and the volumes tick up on what's available, through product forms other than chop, so different variety of non-wovens, different variety of 3D printed forms and so on, we can get these things back into industry that makes sense. The upper left there, which I think everybody in this world has talked about at some point, just talks about all carbon fibers aren't the same. At CarbonConversions, we recognize that, we believe in that, and so we track the different inbound raw materials to segregate out different moduli and tensils so we can create value back to the different customer bases. So if you want to truly close the loop, this is what it looks like. We capture the different waste streams around the edge of the process, and when things get to their end of life, we bring them back as well. We create, through a variety of methods, chopped fiber of different lengths. We can either resize that and give it into compounders, but what we really like to do is make non-woven materials or preforms out of that. We have technology that goes direct to preform through a wet laid process, so you can skip the non-woven value add, and then those can go straight into parts, and you can either infuse those parts today, or a lot of what we're doing with Dell today, and that's very public, and you can go to YouTube and watch the videos that Dell has put out, is we make a chopped thermoplastic carbon fiber hybrid non-woven, and that basically just gets a direct compression mold. So if you're using Dell laptops today, you've likely got our material in your A and your B cover of that laptop, along with some materials from SABIC that we support. So there's a large close the loop happening today, and I think Dell's pretty happy with that, and they talk very publicly about it. So it's great. So when you think about just from the supply chain, how does that look differently? We source different waste streams, whether they be bobbins, cured parts, anything in between. We choose to use pyrolysis and then chop that up into different formats. We also acquire waste streams from some of the other companies that don't have a lot of value add capability, but do recycle into these fuzzier carbon fiber forms. We know how to work with all that. We can turn it into chopped materials, oversized. We can turn it into a variety of non-wovens. We can make those non-wovens into thermoplastic prepregs, or we can go direct to part by going through a preform process where you skip the non-woven altogether. So if you're making something larger like a jet ski, a boat, a drone, things that you could go direct to an infusible component of several square meters, you can save a lot of money by going direct to preform and skipping a lot of the value add of the dry goods and then having to kit cut that and hand lay it up and so on. So the reality is the industry's come a long ways. Recycling in your supply chain and how you get that back in a part can be a bit confusing. It is awfully messy. We think we're pretty good at it. And if you focus on the value add of the different material forms and work with someone like Carbon Conversions, we can usually find a solution that'll get something back to you at a lower cost and better application of a recycled carbon fiber, which helps you with your ESG story. So we provide a variety of forms that are all branded and commercial today and at scale and running. So we have our high strength chop, we have our intermediate modulus chop, different chemistries and oversizings, and then we have our different recycled carbon fiber mat materials, which are really a range of non-wovens, different sizings, different chemistries, different thermoplastics can be put in those. And then we have the commingled thermoplastic fiber mats themselves that Dell is quite happy with, and we've seen some applications in some drone applications and some bracketry and so on. So from those perspectives, there's lots of ways to get at a waste stream of carbon fiber and bring it back into a value-added, formable, curable part where you're getting the benefit of some of that tensile, but almost the entire modulus. Solutions where we see our applications today include everything from laptops and chip trays and finished bike parts and molds for industry and industrial applications around structure and cured parts in automotive. With Collins, we've got an NDA in place. We'll talk about this here just real quick, just because of the aerospace vein here. But we work. So Hexcel is a part owner of CCI. We work with Hexcel, we work with Toray, we work with a variety of aerospace customers. What we really do is try to capture the waste streams, bring it back through this process we've talked about into non-wovens and then back into cured parts. And often we do that under NDA, so we can't talk about a lot of what's going on. But I think the opportunities I would summarize is that if you've got an opportunity out there where you're using a woven carbon fiber today, or you're using any type of non-woven or matte material, or even a very thin layer of unidirectional, where that unidirectional is mostly providing you stiffness, not tensile strength, then these materials have been tested, they are qualified, they're certified, and they actually can replace a lot of that. And we see that with different customers. And so we've got a few pictures here of the types of things one might imagine are commercialized or commercializable or under NDA and being done. And I would just tell you that there's a lot more around this space, to the point that we are actually sold out. So we are looking for more waste streams to capture. We're looking for more raw goods to work with because we've got more customer demand for the value-added products than we actually have raw material to produce, which is partly a COVID supply chain impact on what Dan talked about yesterday and some of the supply and hit from the aerospace, and some of it's just the fact that not everybody is aware that you can recycle your waste streams back through someone like Carbon Conversions. So when we think about the future and what we're working on from a development perspective, there's an awful lot of carbon in wind blades. There's an awful lot of intermediate modulus carbon in aerospace, and there's some fantastic carbon being developed now for pressure vessels. All of these have lifespans. All of these will have an end of life. We are working under NDA in all of these areas today on how to capture that, put it back through into some pretty high value product forms. And in some cases, it goes back into these applications. But in a lot of places, it goes back into a different application where there's plenty of demand for the modulus, and we can convert that through. So how can you help close the loop? This is what we do. If you're thinking about what you can do as a company or as an individual, so my first request would be is if you produce carbon fiber, send your waste streams to a recycler. And if not Carbon Conversions, pick somebody else. But all carbon fiber is recyclable, and if you have it on a bobbin, it can be recycled. If you use carbon fiber and you have waste from your processes, it really doesn't matter if it's a cured waste, a sticky waste, a dry waste, or the ends on the bobbins. All of that can be repurposed. So you should be talking to a recycler, see about what the value of those different pieces are. In some cases, there's actual value for us to pay for it. In some cases, it's just that we ship it away from you. But in all cases, we can recycle it. And then if you make materials in short carbon format, so you are using carbon fiber from a recycled solution today, that would be best. So if you are doing anything in the compounding, non-woven, matte consumption area, and you're paying for and using virgin fiber, there's an obvious choice where you could switch over to a carbon fiber from your supply base. And then if you're a designer, think about the product forms we've just talked about. Talk to us about other product forms that are under development. How could you design those into a future product? How could you, make some of your raw material supply chain an ESG story? And then decide that you and your company can and will close the loop wherever possible is a big statement. And then that helps everybody focus around the top 4 items here about what we're talking about. So it's pretty simple as the concept of how you can help close the loop. And it's basically engaging with the recycling community. This couple days here with this group is a fantastic opportunity to discuss it. But the reality is it really is moving quite rapidly from an R&D, 10 years of discussing how you could do it and why you should do it to we are doing it today. It's commercial, and there's no reason for you not to be doing it. So Carbon Conversions provides products for your processes that are qualified, certified. We're an ISO certified plant. We can help close the loop. Our goal is to be a great partner. We appreciate, given our backgrounds in composites, that not every material form we have solves the problem, right? So we're always developing new material forms. That's part of the industry we're in. All of those new material forms used waste carbon fiber from some form, and that's the ESG story. And then at the other side of it is we're a great partner to take your waste if that's something you want to do, and we can even provide certificates that your material was recycled, and so that you can truly close your loop and talk about your ESG story, and we're part of that. And that's really what I had to talk about and present. Fairly rapid fire there. I tend to talk kind of quick if you know me, but that's the story, and it's a good story. It's a commercial story. We're available anytime to talk about what we can do for you, or what we can sell to you, or what we can consume from you. So with that, I think I'll open it back up for some questions.
Thank you so much, Brett. We do have a couple questions in the chat. I think the first question here from Deborah Chung is that it may be interesting to explore the vibration damping ability of the recycled fiber composites compared to the virgin fiber composites. Any information on this?
Yeah, so the dampening effect has a lot to do with the resin chemistry, and it has a lot to do with your frequencies and your nodes and what you're trying to manage. And chopped fiber form does help break that up, right? So is there better dampening with the types of products we produce than a virgin unidirectional or something? The answer is absolutely yes. The question is are you designing what you're designing originally around dampening because you need that tensile strength, or can you get by with just the modulus and the stiffness and manage it that way? So what I can say hand on heart is that the non-wovens we produce provide you as much, if not more, stiffness than unidirectional and woven prepregs. They're incredibly stiff, especially the heavier weight materials that you can infuse. They are incredibly challenging to turn into a prepreg, though, because of the density in the pack of our materials, but you do give up an awful lot on tensile strength, right? So our materials are great behind a layer of woven, or if you like the more organic look, you can go right into a part with ours, and they certainly help in that way.
Another question, and you started to answer this, Brett, a little bit, but then another question that came right after that. What's your comments on other properties besides mechanical, electrical, thermal properties, for example?
Yeah, so we see good conductivity, depending on how you want to define conductivity. We see excellent compression, excellent flex. But as you move into that discussion, now you're talking about resin chemistries, right? And it's a composite material. So we can provide you different chop lengths that provide you different alignment, different tensile modulus trades. Depending if you put those in a nylon or polycarbonate or an epoxy or polyester, that starts to matter how the whole system performs. But if you're using a traditional 3K standard woven, or a single layer of non-woven, or a mat today of glass or of some other lightweight carbon type product, I mean, we can certainly compete with or displace that in a lot of applications, and that's what has to be explored.
Another question in the chat, do you see carbon fiber waste as being a market itself? And any comments about the price of that as there may be more demand for the carbon fiber waste?
Yeah, no, absolutely. It's a market unto itself. As we see the ESG stories start to grow around the globe and people become more attuned to what an ESG means for their industry and their company, the idea that you're recycling out of your waste streams and that fact that that's going to be highly regulated means there's a waste stream market for carbon fiber. Carbon fiber has a lot of value in the modulus. So if you have a dry fiber bobbin of some size, shape, I mean, it has a value that we would pay for. We have to deal with logistics to get it to us, right? Then we have energy we put into it to turn it into a non-woven, and that has a certain price point in the marketplace, which caps what we can afford to pay for the recycled part, right? And then as you move down that pyramid I talked about, cured parts, we can't afford to pay for cured parts and get them back into a value-added product form, but we can afford to ship them usually so that you're not paying for that waste stream. So it goes back to that pyramid of discussion I showed, and the top of that, we can afford to pay for materials. At the bottom of that, we cannot. I don't know any other recycler saying anything different, but what we try to do is, because of the value we're creating on the back end of our value-added forms, we can usually afford to pay a bit more. But there's definitely a market space, and what I would suggest is you just talk to us about your particular waste streams and volumes, how far away it is from a recycler of a different type, and then we can talk about what the value of that is.
Those are all the questions that I see in the chat. Would anyone else like to ask a question?
Yeah, I have a question. Right, a good presentation, thanks. So far, if you look at the carbon fiber reinforced plastic composite recycling, in general, people more focusing on the carbon fiber recycling. Do you have any comments or suggestion about the matrix? Because some of the thermal process basically just burn off the matrix, especially for those thermal cell. Do you have any comments in terms of how we can use the matrix part, right?
Yeah, that's a good question. I've been asked that a few times. There's a real challenge when you start looking at the resin matrix with how you bring it back around into a part that makes sense, because once you've destroyed the fundamental matrix, you've given up a lot of its value. So if you pyrolyze like we do, you do get the energy back out of it, and that helps you save some of the energy and getting back to the raw carbon fiber. There are a variety of universities working on research projects where you can get at the resin chemistry and you can break it down into some main constituents. You can recover a few of those and you can burn a few of those. But unless you've designed the chemistry to be broken down and recycled, it's very hard to use the chemistries that are available today to do that. And the challenge with designing a chemistry that can be broken down so that it can be recycled is you typically give up an awful lot of strength. And we're in an industry where you're paying an awful lot of money to get an awful lot of strength and stiffness because you're using carbon fiber to begin with. So we have not found or seen a way yet to effectively get at resin chemistry recycling. And we aren't focused on that as a company yet. We think other people will solve that. And when they do, that's great. And we will get the carbon fiber from that process and then bring it back around and close the loop. So other than using the energy from it to help generate more heat to burn off the chemistry, we don't focus on that.
Thank you.
Other questions? I guess we could also be able to continue the discussion into the breakout rooms, and perhaps this will be a good point.
So Ryan, I think is another question from chat.
Oh, I see. Yeah, another question in chat. So the question, what do you mean under good conductivity?
Well, it's different than bad conductivity, but conductivity is one of those moving targets, especially in our world of advanced composites, right? But So we've played around with, you can make a pretty good matte material and needle it, get a lot of Z vertical direction conductivity. You can put some nanoparticles in it, get some conductivity. You can put it into a thermoplastic with a graphene loading, get some better conductivity. We certainly deal with anti-static discharge. We certainly deal with normal, removal of static and light current. When you're thinking about lightning strike, no, we're not talking about that kind of conductivity. I mean, there's a whole different challenge there. So that it's in the realm of think of it as in the realm of a Faraday cage, but not more beyond that.
Great. Well, Brett, thanks again for the wonderful talk. We'll give you the virtual round of applause.
Thank you. Thanks, everybody.